People who exhibit the behavior associated with being addicted to alcohol do not get there overnight. Addiction happens when alcohol causes unusual chemical activity in the central nervous system. In a healthy person, specialized chemicals, neurotransmitters, travel throughout the brain, sending signals from nerve cell to make one behave appropriately in response to what is happening around them. In a person addicted to alcohol, the story is different. Both moderate and heavy drinking can lead to inappropriate aggressive behavior. Many people know that alcohol is a depressant. This is referring to its ability to depress or slow down brain processing. This alteration is a part of the reason a person behaves uncharacteristically and aggressively. This is gamma-amino-butyric acid, or GABA. It is the brain's primary inhibitory neurotransmitter. An inhibitory neurotransmitter is a messenger that acts like a stoplight, temporarily stopping a neurological signal in its path inside the brain. This is a good thing in healthy circumstances. Looking at GABA in its natural surroundings, we find it traveling down the axon of a neuron in the brain. At the terminal end, we find a synapse, the space between two neurons where a signal is transmitted from one to the next through the release of a neurotransmitter chemical. Here, tiny electrically charged particles are found that power a signal into the next neuron. For a signal to fire, the receiving neuron must have a much higher positive charge than negative charge. These charged particles enter the neuron through tiny receptor channels. GABA molecules leave the presynaptic neuron and bind to GABA receptors on the surface of the next neuron. Because it is an inhibitory neurotransmitter, it opens the receptor for negatively charged particles to course through, making it virtually impossible for subsequent signals to fire. Remember, there needs to be a high enough positive charge for a signal to fire, which is very difficult to achieve with such a high negative charge to now overcome. Because of this, signals are momentarily blocked from traveling into the next neuron. When GABA detaches itself from the receptor, the channel closes and negatively charged particles stop going through. The neuron is ready again to receive stimulatory signals. We're used to seeing alcohol like this. But now let's take a look at it like this. Ethanol. This is what makes a drink alcoholic. When swallowed, it goes down into your stomach and digestive tract. The digestive tract absorbs the nutrients from what you just ate or drank. When something is absorbed, it goes into the bloodstream, which will transport it all over your body, including your brain. This all happens within minutes. With alcohol present, the activity of GABA receptors increases. This means it inhibits a signal more often and longer than it normally would. This happens all over the brain. When a prolonged depressant effect happens in the following areas of the brain, the result is clearly expressed as a change in behavior. The cerebral cortex is associated with thinking, decision-making, emotions, and the five senses. The hippocampus controls memory. The medulla is responsible for involuntary processes such as breathing and body temperature. And the cerebellum coordinates your voluntary movements such as walking and picking up objects. Research shows a link between alcohol and aggression and the roles that the chemicals serotonin, norepinephrine, and dopamine might play. We know dopamine to be involved in the reason people become addicted to alcohol. Dopamine is found in the mesolimbic reward pathway in the ventral striatum. When you do things that are necessary for survival, such as eating food, drinking water, and having sex, it courses around this circuit of interconnected neurons in the brain, making you feel good. You are subconsciously rewarded for doing that action. Unfortunately, ethanol drives dopamine to make you feel extra good for drinking alcohol. To better understand the brain's reward system, consider this. When you give your body food or water, your brain rewards you with a feeling of satisfaction. This encourages you to repeat the action, making your brain and whole body happy. When you start giving your body alcohol, your brain rewards you with a more sizable feeling of satisfaction. This encourages you to drink more and continue the euphoric feeling. But alcohol is different from food or water. The brain actually becomes desensitized to alcohol the more you drink it. This means that drinking the amount of alcohol that made you feel great in the past doesn't make you feel nearly as good, so you drink more. With more and more alcohol present in the system, the damage goes beyond the brain. Exposure to alcohol will cause damage to the esophagus, as well as the stomach, liver, and kidneys. When rewarding oneself with a drink, think about the implications to the brain's built-in reward system. Current research shows that heavy alcohol use is linked to aggression and can lead to the following: violent crime, breakdown of the family, behavioral health problems, unemployment, disrupted friendships, legal problems, and various medical conditions. If you are experiencing any of these, or you feel you need help, please refer to the following resources. Help is available.